In all of our examples of linear systems of differential equations, we've been able to find the general solution, but we haven't yet looked at imposing an initial condition. So let's revisit example 3 that we found the general solution of before and impose an initial condition. That is, let's find the solution to the initial value problem given by the differential equation y prime equals negative 5, 2, 1, negative 4 times y with the initial condition that y of 0 equals the vector 7, 1. Now we already found the general solution to be y of t equals c1 e to the negative 3t times 1, 1 plus c2 e to the negative 6t times negative 2, 1. To find the solution to the initial value problem, it remains to find the values c1 and c2 using the initial condition that y of 0 equals 7, 1. To use this piece of information about y at 0, we will evaluate our general solution at t equals 0. To get y of 0 equals c1 times e to the negative 3 times 0 times 1, 1 plus c2 times e to the negative 6 times 0 times negative 2, 1. On the other hand, we know from our initial condition that y of 0 is 7, 1. Simplifying the right-hand side, we have that e to the negative 3 times 0, or e to the 0, is 1, as well as e to the negative 6 times 0 is 1. So multiplying by our constant c1 onto 1, 1, and c2 onto negative 2, 1, and adding our vectors component-wise, we get that the right-hand side is c1 minus 2c2, c1 plus c2. Since this is equal to the vector 7, 1, we are left with a linear system of equations. From the top component, 7 equals c1 minus 2c2, and from the bottom component, 1 equals c1 plus c2. And we can solve this linear system in several ways. One way to do it is to subtract the first equation from the second to get 3c2 is equal to negative 6, and thus c2 is negative 2. And knowing that, we can plug it into either of the equations to get that c1 equals 3. So we can conclude that the solution to the initial value problem is y of t equals 3 times e to the negative 3t times 1, 1 plus negative 2 times e to the negative 6t times negative 2, 1. As with examples of differential equations from earlier in the course, when we want to solve an initial value problem, we will first find the general solution and then impose our initial conditions.